Okay, 5.2 is permutations and factorial notation. Okay, so let's talk about a permutation. It's an arrangement of distinguishable objects in a definite order. For example, the objects A and B have two permutations. You could go AB or BA. So how many arrangements can 6 children form when they're lining up to get a drink? Okay, so we're going to talk about factorials. So this is 6 factorial. So what is a factorial? It just means that this expanded would be 6 times 5 times 4 times 3 times 2 times 1. Okay? I'll do one by hand. I'm not going to do that one by hand because it's too large. But let's talk about 3 objects. If you're rearranging 3 objects, so you could go A, B, C, or you could go A, C, B, right? Now, so that's the only 2 ways I could put A first. Now if I put B first, I could go BAC or BCA. And now if I put C first, I could go CAB or CBA. So you can see that they arranged in 6 different ways. So 3 objects got rearranged. 3 factorial. So that's 3 times 2 times 1, which is 6. So you can see how that works. Okay, so 6 children rearranged, 6 factorial, okay? But you don't have to type all that in, 6 times 5. So there's a button, so if you're in one of these, 6, here's my button on this one, the factorial button, so second function looks like that, and it's 720. So in your graphing calculator, this button is in your math under probability, and then you can see it there. So I have to type the 6 in first, so 6, math, probability, and then factorial. Okay, factorial notation, a concise representation of the product of consecutive descending natural numbers. So you could see that 6 factorial is the product of all of the numbers descending from 6. Okay, so if I have n factorial, the first number would be n, and then n minus 2, or n minus 1, n minus 2, all the way. Obviously, this cannot go any lower than 1. You can't go 0 or negative numbers. Okay, so 4 factorial is 4 times 3 times 2 times 1, which ends up being 24. Okay, so evaluate 10 factorial. So again, we're not going to go 10 times, 9 times, 8 times, etc. So 10 factorial is, see, that was a very large number, 3628800. Okay, evaluate this one. Okay, I'm going to show you a little bit of a different way this time. So 12 factorial, I'm going to start to expand 12 factorial. So 12 factorial is 12 times 11 times 10 times 9, and then on and on and on, right? But I can see now that the rest of that piece is going to cancel with this. So that's going to cancel. Okay, and then you can simplify some more things here. I know this is 6, and this is 12, so that can cross off to 2 and 1. So now I have 2 times 11 times 10. That's the only thing remaining once I've canceled. Okay, and yes, your calculator probably would have done that, but sometimes you might have very, very, very large numbers that your calculator can't even handle it. So this would be the only method.
This is the first time I walked by your class and you didn't have millions of students in here.
Mm-hmm.
Have you started your comments for next semester already? But you've done your comments?
Maybe. Close. So you can see how you get to the same answer. Okay, simplify this. So n plus 2 factorial, but then there's an n plus 3. So really, we could have just stated this as n plus 3 factorial. You see how that, if you just go up 1, you can also just include that. That'd be like me saying 10 times 9 factorial, right? I can just really say that is 10 factorial. Okay, so here I have a fraction, so I'm going to start to expand the larger numbers. So out of n plus 1 or n minus 1, this is larger. So n plus 1. So if you decrease, go down, the next one's n, then n minus 1, and then I can see that the rest of that descending order will cancel this descending. And since it said to simplify, I'm going to take this and I'm just going to expand it through. So n squared plus n. Okay, now I have an equation to solve. Okay, so again, same kinds of strategies where you're going to expand the larger one. So this is the larger. So n descend down, and that is where I'm going to stop once I've hit to something that's going to cancel. Okay, so now I'm going to take this piece that's left and expand it, n squared minus n. Okay, so now we're at a point where we should have known what to do from grade 11. I would want to make this a quadratic equation by moving the 90 over, and I would try to solve by factoring. And then I'm going to use a 10 and a 9. So n equals 10, n equals negative 9. But I know that I cannot have a negative number that's a factorial. So this solution is eliminated, and therefore my answer is 10. Let's just double check. 10 factorial divided by 8 factorial. 10 times 9 times 8 factorial. So that would end up being 90.